Welcome everyone. Today we are going to learn about Vedic division. Now, what are we going to learn today? Today we are going to learn the definition of division terms, splitting method for division, division method by 9, longer numbers in the divisor, finally the split method and division by 99. Now, first I will define the division terms. Divisor. Divisor basically represents that the number that we want to divide by. The dividend. Dividend means the amount that we want to divide up. That means we are basically dividing the dividend by the divisor. And now quotient. Quotient means a result obtained by dividing one quantity by another. And what is remainder? Remainder is the amount left over after the division. Division terms. I'm taking a simple example, very simple example. Let us take an example where we need to distribute 20 biscuits among 8 students. Here 20 is to be divided by 8. So the dividend here is 20. The divisor here is 8 because we need to distribute 20 among 8. The quotient here is 2, as we can distribute 2 biscuits to each student, and then the remaining 20 minus 8 into 2, that is 20 minus 16, that is 4, will be the remainder. Now, the basic remainder theorem. The remainder theorem follows and can be proved by example is expressed mathematically as dividend equal to divisor into quotient plus remainder. From the previous example, we can construct 20, that is the dividend, equal to 8, that is divisor, into 2, that is quotient, plus 4, that is remainder. Now, I am coming to the first method, that is splitting method of division. Simple division of divisor with single digits can be done using the method. Now, I am taking a simple example of it. The number 822. We need to divide 822 by 2. Now, the number 822 can be split into 8/22. That is, I am just splitting the number 822 into two parts. The first part is 8 and the second part is 22. And we get, after dividing by 2, that for the first part will be 8 by 2, 4, and the second part will be 22 by 2, that is 11. Because 8 and 22 are both easy to halve, therefore 822 by 2, that will be 411. Now, let me take another example of it. We have seen that for 822 by 2, we are taking the parts as 8 and 22. But if I just change the problem a bit, say 634 by 2 here. Here the parts should be done in this way: 6 dash 34, and then the parts will be 30. The first part will be 3 after dividing 6 by 2, and the latter part will be 17. But if someone wants to divide it as 63, as 4. Then what will happen? We know that 4 can be divided by 2, but 63 can't be divided by uh, 2. Yes. Then what can be done? Then for this method, we will first reduce 63 by 1. That will be 62. And then we will divide 62 by 2, and we'll get the result 31. And for the next number, I mean for the second part, here the second part is 4. But as we have subtracted here 1, we need to add the 1 to the latter part. So the latter part will be 14 by 2. That is 7. So the total answer will be 317. So for by 2, if we can't divide a particular part by 2, then what can be done? For the first part, I am subtracting 1 from it, and then adding the subtracted one with the second part to get the final result. Okay. Now I am coming to another method, that is the method of division by 9. There is a very quick method to compute the division by 9. Now, let me take an example. Let me take an example that 71 by 9. 71 by 9 gives the quotient 7, remainder 8. And adding the figures of 71, that means 7 plus 1 equal to 8. So 71 by 9 equal to 7, remainder 8. It is easy to see why this works, because every 10 contains 9 with 1 left over. That means I am again defining the concept of base as I have defined in the subtraction. Now here I am taking 10 as the base point and considering 10 as 9 into 1 plus 1. That means 10 is basically 9 plus 1. Now we know that every 10 is a contain is the addition of 9 plus 1. Then 71 will be how much? 70 plus 1. That means 7 times 10 plus 1. So 2 tens will contain 2 times with 2 left over. So 7 tens will contain 7 times. Yes. So we know that the quotient will be 7. Now it is very easy for this method to determine the quotient by seeing only the number which is to be divided. How? Let me take another example to see. If I take, say, 56 divided by 9. So how much will be the answer? 56 divided by 9. Now, we know for the remainder, what can be done? We need to add the digits, okay? Then we need to add the digit 5 plus 6, that is 11. That is 11. So, need to just, we shall do 11 divided by 9. So, how much is 11 divided by 9? It is 1 with remainder 1 with remainder 2. So I am not going to the quotient part because I am only to get the remainder from this formula. So what will be the remainder? 2. So just by adding the digits of the number, I am getting the remainder. And now for the quotient, I will check the number of tens for the nearest base. So what will be the nearest base of 56? That will be 60. So I am taking the nearest base of 56, that is 60, or 60 equal to 6 into 10. So we know that each 10 contains one 9. I am again repeating the statement, each 10 contains one 9 and gives a remainder 1. So I am not getting to the remainder because the remainder we have got from the digit method. Okay, so by adding the digit we have got the remainder. So I am just computing the quotient. So how much will be the quotient here? The quotient will be 6. We can say directly, because the number here, the base near the number here is 60. So 60 is basically 6 into 10. So if 110 contains 19, so how much 610 will be will contain? 6 into 10 will contain 6 nines. So there will be 6 total nines and a remainder of 2. So 56 is basically 6 into 9 plus 2. Here 9 is the, sorry, 6 is the quotient and 2 is the remainder. Okay. Now I will get another example of division, which is called longer numbers in the division. That means I am not taking the divisors as 7, 8, 9, etc. I am taking the divisors as a long number. Now, what can be done in this situation? The method that is I have done with divisibility by 9. Now the method can be easily extended to longer numbers also. The same method. Suppose we want to divide the number 12353. There is a 6-digit number by 99. This is a very similar to the division by 9 method, but because of 99 has two nines, we can get the answer in 2 digits at a time. So let me explain the statement why we can get the 2 digits at a time. Because we know that if we divide a number with 99, we can get the remainders as 0 to 98. So we can get a remainder of say 67 also. Okay, 67, 71. So 2-digit remainder can be generated through the example. Okay. Now, first of all, we will divide the number into 3 consecutive pairs. So here the number is 1, 2, 3, 5, 2, 3. Now I will divide the number as the first part will be 1, 2, the middle part will be 3, 5, and the latter part, the last part will be 2, 3. So I am dividing the number as 1, 2, 3, 5, and 2, 3, where the last part, the last pair is part of the remainder. Why the last pair is part of the remainder? We know that we can get the remainder uh, after the last step of the division. So let me describe the steps. First step. First step, we will put down the number 12. Why 12? Because the first part here was 12. Then we need to add 12 with the next part, that was 35. that is 35 plus 12, that will result in 47, and put it down together. And then we will add the 47 that was generated from 12 plus 35 with the final part, that is 23, and we'll put it down. So the result will be 70. Here the remainder is 70, because we know that if we add those digits, what we will get? The remainder. And what will be the quotient? The quotient will be 1247. Now how we can generate the quotient? By just checking the method. We will generate the quotient just by seeing the method, because the quotient here will be the first part followed by the second part. That is, here first part was 12 and the second part was 47. The first part was 12 and second part was 47. So how much will be the quotient? That will be 1247. Now let me explain the thing with another example also. Now let me divide another 6-digit number. Here the 6-digit number is 21342. Now we need to divide it by 99. Okay. So what was our step 1? Our step 1 was put down the number as 21 slash 34 slash 23. By slash we are defining the parts. Okay. Now I am writing the division from and just making some gaps to divide the parts. Okay. What will be the second part? The second step was putting down the first part, right? So if we put down the first part, there will be 21. Yes. Now I am putting down the first part, that is 21. Okay. And what we should do at next? We will add 21 to the middle part. The middle part is 34. Now we will add 21 to 34. Then, then the result will be, then the result will be 21 plus 34, that is 55. And then we need to add 55 to the last pair. Now what is last pair? Last pair is 23. So the final result is 55 plus 23, that is 78. So what will be the final result? The final result will be the remainder. So the final result will be the remainder, and as usual, what will be the quotient? The quotient will be 2 1, and the next addition, that means the next sum. The next sum was 21 plus 34, that was 55. So here the quotient will be 2155. So how we can just see and say the method, or say if I don't have any sheet of paper and if I have to do it mentally, so how can I proceed? I will just take the three parts and then write down the first part and the sum of the first part and second part consecutively. and that will be our remainder, that will be our quotient. So here the first part was 21, the second part was 34. So how much will be the quotient? 21, and then followed by 21 plus 34, that is 55. So 2155 will be the quotient, and what will be the remainder? The sum of the three parts, that is 21 plus 34 plus 23. Now if the sum of the three parts go beyond 99, that then we need to check for the divisibility. We know that if say if we got 101, then what will happen? That will result in 1 with remainder 2 when divided by 99. So as simple as that. Now division by 98. We have checked for 99. Now I am going to the division by 98. Now, let me take the example, because for these methods example is very important and we need to practice many examples. Now let me take a basic example, that is the number of 6 digits 122,316 divided by 98. Okay, so first step is that this is the same as before, but because 98 is 2 below 100. Now what is 2 below 100 and why we are taking 2 below 100? What does the phrase mean? The phrase actually means that I am again taking the base for the division. Why I am taking the base repeatedly? Because we know that what is division. If we just explain division as the anti method or the reverse method of multiplication, we will know that multiplication by 100 or division by 100 is a bit easy. So I am again taking the base to just make the calculation simple. Okay. So we know that 99 was 1 less than 100, and now 98 is 2 below the 100. Now, as 98 is 2 below the 100, we need to double the last part of the answer before adding it to the next part of the sum. So let me proceed with the method. So we begin as before by bringing 12 down, because here the parts will be one. The first part will be 12, the second part will be 23, and the last part will be 16. So I will put down the first part as usual. So the first part 12 is brought down. So 98 divides 12 slash 23 slash 16 will get the put down number as 12. Now what can be done at next part? For the 99 part, we directly added the first part with the second part. But as 98 is 2 below 100, we need to add twice of the first part to the second part. So twice of the first part is 24. That means 12 into 24 plus 23 will get the result 47. Now, finally, I will add the double of 47 to the last part, that is 16. Again, the double of 47 will be 94, and while adding to 16, that will result 110. Here 110, we know 110 is greater than 98. So what can be done with 98 thing? Remainder can't be 110 while dividing 98, because then the remainder should be from 0 to 97. So what can be done in this scenario? In this scenario, 110 can be divided in 12 modulo 98. That means 110 is written as 98 into 1 plus 12. That means we are basically taking the modulo operation here. So I will give you some application of the modulo operation with Vedic math later on. But here I am taking the modulo operation, the basic modulo operation. That is 110 equal to 98 plus 1 plus 12. Now the quotient one what we have got after dividing 110 by 98, the quotient one will be added to the previous number, that is 47, to get 47 plus 1, 48. Okay, so what will be the remainder? The remainder will be 12 followed by 48, not 12 47. Why not 12 and 47? Because I am getting the sum as 110. I am repeatedly talking about the method, that is when we are getting the sum above 98 or greater than 98, we need to put the modulo operation and we will add the quotient with the previous number. Here the quotient is 1 and remainder is 12, because 110 equal to 98 into 1 plus 12. So we will add the quotient to the previous result, that is 47 plus 1, that will be 48. So what will be the quotient here? 12 and 48, and the remainder is 12. Why 12? Because the sum will result in 110 and the final remainder will be 12. So this method is very easy. Now, split method. Like addition and subtraction, split method can be done for division also. Yes, in Vedic mathematics, the splitting of the numbers plays a very important role. But why the splitting of the numbers is repeatedly coming to our discussion, and why this is very important? Because here I am not actually splitting the numbers. What I am doing, I am just breaking the number with my imagination. Okay, so breaking the number into simpler parts are nothing but a method to make the calculation simple. So if I want to make simpler calculations, I can always do in this way, that I am getting a 6 digit or say a 8 digit number. Here I am taking the 4 digit example, but when we will be given a 6 digit, 8 digit, or say maybe a 12 digit number also, if we can split some parts with a 2 digit gap. I mean, if we can break a 12 digit number into 6 2 digit numbers, then the method will be just like the 2 digit division. Okay, so I am basically by splitting making the calculation simpler one, nothing else. So by split, we know the splitting method for addition. We have seen the splitting method for subtraction also. Now I am taking the splitting method for division. Now the method is very similar. What we need to do, for example, if we have 12 46 by 2, then we will break 12 and 46 into two parts, 12 and 46. Then we will divide it 12 by 2 and 46 by 2 separately. Okay, so we have known that in earlier slide I have shown the method, the very similar method. But what is the difference? The difference is that by split method, we can do a larger number also. We can do the splitting of a number in more than two parts also if required. For example, when a big number, say 256085, is divided by 5, then we can make the three parts as 256085 as 25, 60, 85, and then divide each part by 5. Okay. Now let me take another big example. Say, say I am given a number, say 33, then followed by, okay. So this number is to be divided by 3. Okay. So I am making how many digits are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 digits here. So I am making the parts as 33 slash 32 slash 78 slash 93 slash 39 slash 21 slash 12, and I will divide each part by 3. So 33 divided by 3 is 11. Then the next part will be 14. Then the latter part will be 26. Then 31. Then 13. Then 7. But here we will write as 07 because there will be 2 digits, and then the final result is 3. Sorry, 12 by 3 will be 4, but we will write as 04. So the final result is, so it is divided by 3. I am writing it as this, will result in this. So the final result is 11, 14, 26, 31, 13, 07, 04. It is going in this way. Now we can do the same problem. The same problem by another method also, or by another splitting basically. So how we can split in another way? We can split 33 as 3 slash 3. Okay. Then I am taking the part as 42. Then I am taking the part as 78. Then I am splitting 93 as 9. Then 39 as 3, 9. Then 21 will be the part, and 12. So I am basically taking the multiples of 3 as another parts also. So here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts. So I am breaking it in 10 parts, and then I am dividing it by 3. I will get the result. Okay, the same result I will get. So I can do by 10 parts also. So this method can be done for a longer number, and the splitting method is very helpful for a longer calculation. And basically when I am dividing by 3 or dividing by 2, we can also split the parts by our imagination. What we have chosen is the matter, so we can choose in very different way also. Now thank you for showing the Vedic division video. Later on I will introduce the Vedic division applications to you from some number theoretic aspect and divisibility.